All right, guys, in this video, we're going to talk about finding the improper integral with an infinite discontinuity. So we've done improper integrals where one of the limits of integration is infinity or negative infinity. So this time, it's the same idea, but this time, if we have a value within the limits of integration that has a vertical asymptote, infinite discontinuity, vertical asymptote. So this says if f is continuous on the interval at a all the way up to b, and there's an infinite discontinuity at b, or vertical asymptote at b, then the integral would be equal to the limit as some variable goes to b from the left, from a to c, so that's c. C goes to b from the left. So if I'm thinking about this, if I have like a graph like this, it's got an infinite discontinuity right here at b, and then it wants to go from a. If I want to find the area under this curve, I would say this is the limit. So actually I would take a step back. I'm doing the integral from a to b of our function. But if b is the vertical asymptote, I'll do the limit as c goes to, and I'll say something in a second, a to c. Now I'm approaching b, but I'm approaching b from the left. So that's why we're going to, c approaches b from the left of the function f of x dx. If my limit, or if I'm having an improper integral where my infinite discontinuity, my vertical asymptote is on the left side, where a is, so here's a, try to just look over the words. From a to b, it's the limit as c approaches a from the right, because I'm trying to get it from the right side, the integral from c to b f of x dx. And that's what that says. And we'll do an example in a second, it might make more sense. If f is continuous and the infinite discontinuity is somewhere within a to b, then I would kind of combine those two ideas. Like do it from all the way up to the right and then all the way up to the left. We'll do an example. All right, so also, if this limit diverges, then the whole integral diverges. If it converges, then the integral converges to that number. For this, if either one diverges, the whole thing diverges. So an improper integral with an infinite discontinuity, as I'm looking at this, I would just feel better if it said 0 to 1, 1 over the cubed root of x dx. I'm looking at this and I think, okay, where is my vertical asymptote? A vertical asymptote is a restriction on x that makes the denominator 0, right? So if I plug in 0, I'd have 1 over 0. So my infinite discontinuity is right there at 0. So that one's like 1 on the left, so maybe it looks something like this, but maybe not. Either ways. So the infinite discontinuity is at 0, and it's the one like on the left, so it's a case number 2. So I would say this integral is equal to the limit, and I'm just going to say a, or I could say b. I'm going to say a because it's a lower one. On the notes it says c, but I'm just going to say a. As a approaches 0 from the right of the integral a to 1 over cube root of x dx, and I'm going to solve this. So that would be equal to, I'm going to rewrite this, limit as a goes to 0 from the right, integral from a to 1, x to the negative 1/3 dx. Find the actual integral, antiderivative I mean. A approaches 0 from the right, add 1 to get 2/3, multiply by the reciprocal, so 3 over 2. And I evaluate that from a to 1. So this would be equal to the limit as a approaches 0 from the right of 3 over 2 minus 3 over 2. Now plug in, so I plugged in 1 and got 3 over 2. Now plug in a, and that'd be a to the power of 2/3. And what does this equal? Okay, so this part right here, I might want to rewrite that as 3 over 2 minus the cube root of a squared. Now, if I'm doing a, the cube, or as a approaches 0, that limit, the cube root of 0 is just 0. 0 squared is 0, so it'll just be 3 over 2. So I would say the integral converges to 3 over 2. All right, let's do another one. All right, so number 7. This is an improper integral that diverges, and so let's see what happens. I'm going to rewrite this as 0 to 2, 1 over x cubed dx. So where is the vertical asymptote? The vertical asymptote happens when x is equal to 0. So I'm going to rewrite that as the limit as a approaches 0. And when it's the lower limit, it's going to be as it approaches 0 from the right side. If it's the upper limit, like over here, it's as I approach that upper limit from the left. And it's not always going to be 0. It's just whatever your vertical asymptote number is. This one just both has been to be 0. Of a to 2 x to the negative 3 dx, which is equal to the limit as a approaches 0 from the right. Find the antiderivative, so it'd be add 1 to the exponent, multiply by the reciprocal. Evaluate it from a to 2. This would be equal to the limit as a approaches 0 from the right. Okay, let's plug in 2. So it'll be negative 1 over 2 times 2 squared, so it'd be 1 over 8. So minus whatever you want to plug in a, but when I plug in a, I'll get a negative, so I'll add, that'd be what? 1 over 2a squared. Now if I evaluate this limit as a approaches 0, if this approaches 0, if the denominator is approaching 0, the overall number is growing without bound. This is negative 1/8 plus infinity, basically. So this would be like infinity. So this integral diverges. It does not, you can't add up all the sums. It's just too much. It just keeps adding and adding and adding. It keeps growing without bound. All right, last example, an improper integral with an interior discontinuity. So again, I'm going to rewrite this. We know, we just did it, the vertical asymptotes when x is equal to 0. So that's the infinite discontinuity, and that happens within those limits of integration. Again, the vertical asymptote won't always be 0. So I'll need to split this up. I would say the limit as a approaches 0, and I'll just take a second. So the, actually, I might say b here. We'll call this b just because I usually label the bottom one a and the top one b. So if I say from negative 1 up to a, because negative 1 is that first limit of integration. Let me draw a little picture. So here's your graph. It looks something like this, right? So I'm trying to find from negative 1 to 2, but the vertical asymptote is right here at 0. So I want to find that area and add them together. So the limit would be from negative 1 up to a, but I'm approaching, oh, I just said I would call that b. Let's call it b. The limit as b approaches 0, and I'm approaching 0 from the left, of 1 over x cubed dx. And I'm going to add that to the limit as a approaches whatever, we'll find in a second. So this is going to be from, we could call it, actually, let's just call it b again. Maybe that's why we should call it c. Just some variable. It's going to be the same number, though, right? Let's see, what did the notes say? Did it do something different? It calls it the same one, so I'll call it the same thing. Let's just call it b. As b approaches 0, but this thing is going to be from the right, because b is our lower limit of integration, and I'm going to get to b, I'm going to get to 0 from the right, all the way up to 2. Of 1 over x cubed dx. So we could call those B's, we could call them A's, and this one right here, I might actually go back and call them C's just to make it a little bit more clear. So it's just some number in between. We call it A is usually -1. It's the lower limit, B is the upper limit. But in this case, since they're using both of them, we're gonna call it C. All right, so we're gonna do each one. So this would be the limit as C approaches 0 from the left. I'm gonna write this as x to the -3. So this would be add 1 to the exponent, -2. I'll probably show -1/2 from -1 to C. I'm gonna add that to the limit as C approaches 0 from the right, the same thing. To 2. And then we gotta see what we get. Okay. So just pause, make sure that's making sense to you. Now let's evaluate the limit. So this is going to be equal to the limit as C approaches 0 from the right of -1 over 2C plus, because I'm going to wind up subtracting, I'm plugging -1, it's going to be a -1 over 2, so it'll be plus 1/2. Plus the limit, whoops, I made a typo here. Limit as x approaches C from the 0 from the right of, okay, plug in 2, what is that going to be? -1 over 8 plus 1 over 2b squared. Not b, C. Let me show it squared over here. Okay. All right, so now to find this, what would this be? The limit as, if I plug in 0 from the left, this is gonna wind up being like an infinity, right? No, 0, so the bottom is approaching 0, so the bottom is getting really, really small. This overall number is getting huge, huge, huge negative. From the left, actually it's getting huge positive, but it doesn't really matter. This part is approaching infinity, so since that diverges, the whole thing diverges. So the integral diverges. Now it's important to be able to kind of think, if it's approaching 0 from the left, I mean technically that's positive. No, it would be -infinity, right? Because it's squaring it. It doesn't really matter because infinity or negative infinity, either way, is diverging. But this could make problems coming from the right and from the left. So just be careful that you remember how to do those limits. All right, that's it for this video. If you have any questions, next time I see you in class, make sure you ask them. And thank you for watching.